We're going to summarize the steps required to solve this linear first order ODE. This is actually an initial value problem because I do have an initial condition, y naught, y at time 0 equals y naught. So we know that we solve these using an integrating factor, and I'm going to summarize the steps. So step 1, check your equation is in canonical form. Check the equation is in canonical form. If it is not in canonical form, put it in canonical form. Step 2, identify the P function and the Q function. This is crucial, and a lot of students make them manage to confuse them, right? If your equation is written correctly in canonical form, it's obvious. P is associated with Y, right? Q is all on its own. That's essentially it. Make sure that you have the sign correct as well. So if this was a minus sign, you've got plus minus something, right? So that sign is associated with the P of t. We'll see some examples of that shortly. For now, our second step is to identify P and Q. Step 3, compute R of t. We know what our integrating factor is. We know that it's always going to be e to the integral of p t dt. We simply have to integrate p. Once we've identified it, we integrate it, and we take that result and put it in the argument of an exponential. Now, step 4, or the next steps, they're kind of up to you how you wish to proceed through the solution. So I'm going to label them with letters. 3A. Multiply your ODE by R of t. So that gives RT dy dt plus RT pt y equals RT qt. I like to call this the collapse step. You collapse the left-hand side. You know you put a lot of effort in to deduce your integrating factor so that this left-hand side can be written d by dt of R of t times y. That's it. So you have a directly integrable equation. Now we integrate the directly integrable equation. Finally, we can write our solution for y. The general solution. Y equals integral RT QT dt over R of t, where R of t is equal to the e to the integral of p of t dt. When one completes this integral, one will obtain a constant of integration, right? This integral. You get a constant of integration that pops out there, and if you're given an initial condition, you can substitute the initial condition to find C. So again, this is a step that is, if applicable. You only have one initial condition. All right. So that's how one solves a problem, a linear ODE initial value problem. These, I like to do them. Every time I solve a linear ODE, I write down those steps. I still do it, even years after undergrad. If you're comfortable jumping to this and recalling this formula accurately, that's fine. You can jump to the formula. Normally, I wouldn't give that formula in an exam. However, this year all exams are open book, so you can obviously just go and look that formula up. Indeed, there's nothing stopping you from typing this equation into Wolfram Alpha. Right. So, in terms of exam questions, because of the online nature of this course, I've got to think that testing this equation is more about testing your understanding of these steps rather than asking you to demonstrate a mechanical ability to work through each individual step. So I really urge you to understand each of these steps, because you're going to be tested on your understanding, not your ability to crank out solutions to ODEs.